What's up, guys? Today we're going to be factoring quadratic trinomials with a leading coefficient that is greater than 1. Alright, here we go. Alright guys, before we get into the factoring, let's go ahead and remember what the generalized form of a quadratic trinomial looks like. Okay, we have ax squared plus bx plus c. So the coefficient of x squared is what we call a. So in our example here, a would be 5. The coefficient of the linear term, or the x here, would be called b. So in this case, b would be 32. And then c is your constant term. So in this case, c would be 12. So I'll just be referring to those numbers as we go ahead and go through this. So here we have a quadratic trinomial where a is greater than 1. So typically the factoring process is a bit more involved when a is greater than 1. So how this works is the first step is you're going to go ahead and multiply a and c together. So in this case, we're going to multiply 5 and 12 together. And the reason for this is a little bit involved, and so I'll save the reasoning for a different video. So we're just going to take care of the technique in this one. So step 1 is to multiply a and c. So 5 times 12 is 60, all right? And now we're going to take the factors of 60, the factor pairs of 60, that add to 32. All right, so we need two numbers that multiply to 60, positive 60, but add to 32. And those two numbers are 30 and 2. All right, so 30 and 2 will multiply to positive 60, and they'll add to 32. So what we're going to do here is we're going to rewrite this trinomial, or this expression, should I say, and we're going to, instead of writing 32x here, we're going to break that 32x into plus 30x and then plus 2x. All right, so I've just rewritten this expression, except I've strategically substituted 32x for 30x and 2x, right? Because 30x plus 2x is 32x, so I haven't actually changed anything here. All right. And now what happens here is this method's called factoring by grouping, and this is why it's called that, because now we're going to treat this in two separate groups. We're going to treat the 5x squared plus 30x as one group, and then we're going to treat the positive 2x plus 12 as a second group. And now what we're going to do here is we're going to take one group at a time and factor out its greatest common factor, its GCF. So the greatest common factor of 5x squared and 30x is going to be 5x, right? Because they both have an x in common, and 5 goes into 5 as well as 30. So 5x is the greatest common factor. We're going to go ahead and factor that out. And so when we factor that, we're doing the distributive property, but in reverse. So 5x times what will give me 5x squared? Well, that's just x, then plus, and then 5x times what will give me the 30x, and that's going to be 6. All right, so we factored out this first, we factored this first group here, and now we're going to go ahead and factor the second group. So the GCF of the second group is going to be a positive 2. So I'll factor out a 2. 2 times x gives me the 2x. And then 2 times 6 gives me the 12. And now it's no coincidence that there's an x plus 6 in both of these products. All right, so if that doesn't match, it means something went wrong. And now what we're going to do is we're going to treat this x plus 6 as a common factor between this product here and this product here. So we're going to factor out that x plus 6. We're going to pull this x plus 6 out front. All right, so we factored out the x plus 6, and now we do this distributive property backwards. X plus 6, the quantity, times what will give me this? Well, that's just going to be whatever's left. That's the 5x. And then x plus 6 times what is going to give me this product here, and that's whatever's left. That's the 2. So we have plus 2. And so this is the product of binomials that this trinomial factors into. And if you want to check your work, you always can. You can do the distributive property, right? X times 5x gives you the 5x squared. X times 2 gives you the 2x. 6 times 5x gives you the 30x. That totals to 32x. And then 6 times 2 gives you the 12. All right. So now in this example, we have some different signs, so this gets a little bit more tricky. But step 1 remains the same. We're going to multiply a and c together. So 2 times -9 is -18. And so I want the factor pairs. I want the factor pair that'll multiply to a -18, but then add to -7. So that's going to be a -9x and a positive 2x to give me the -7x. All right, so I'm going to rewrite this trinomial, except I'm going to replace the -7x with a -9x and a positive 2x. Because again, -9x plus 2x gives me the -7x, and -9 times 2 gives me -18. Okay, so I've just replaced the -7x with these two here. All right, and now I'm going to treat this as 2 separate groups. All right. And I'm going to factor out the GCF of this first group. In this case, it's just going to be x that I'm factoring out. And then x times 2x will give me the 2x squared. And then x times -9 will give me the -9x. So that group is now factored. And now for my second group, the GCF is just 1. 1 is the only thing that will go into 2x and -9 evenly. And so I'm just going to factor out a 1 here. And then 1 times 2x will give me the 2x. And then 1 times -9 will give me the -9. So that ends up just being the same. And now, just like in our first example, we have a common factor here. Okay, 2x minus 9, the quantity, is a common factor between these two products. And so I'm going to factor that out. I'm going to pull that out front. Okay, and then 2x minus 9 times what will give me this product? Well, that's just whatever's left, that's the x there. And then 2x minus 9 times what will give me this? And that's just the +1. And so there is your product of binomials. That's the factored form. And you could, again, check your work with the distributive property. All right, we'll do one more here. So step 1 is to multiply a and c. That's going to be a positive 42. Right, 6 times 7 is 42. And now I want the factor pair of positive 42 that will add to -17. So the only way to do that is with 2 negative numbers, because again, they have to multiply to positive 42. So the only way to multiply to a positive 42 is if I had 2 negatives or 2 positives, but I also need them to add to a negative, so they can't be both positive. They have to be both negative in this case. And so the factor pair of 42, considering the fact that they're both going to be negative, that'll add to -17, is going to be -14 and -3. And so I'm going to rewrite this expression, except instead of negative 17x, I'm going to do negative 3x minus 14x. Because remember, negative 3x minus 14x equals negative 17x. So I haven't actually changed anything. And then I have my plus 7. Okay. Now I'm going to look at my two groups. Okay. Don't forget that this negative sign here belongs to this second group here. And now I'll factor out the GCF. So the GCF of 6x squared and negative 3x. I will factor out a 3x. 3x times 2x gives me 6x squared. And 3x times negative 1 will give me the negative 3x. So there's my first grouping. Now this is a little tricky here, because remember, I need to get my factor to match. I need a factor over here that's going to match my 2x minus 1. But since I have a plus sign here, I need to get that to be negative so that it'll match this. And so I'm not just going to factor out a positive 7, because then this sign won't change. I'm going to factor out a negative 7. And you'll see why in a second. So I factor out a negative 7. Now negative 7 times 2x will give me my negative 14x. And now the negative 7 times a negative 1 will give me my positive 7. So now I have matching factors here. All right, so whenever you see that the sign in your factor doesn't match the sign in your group at the end of your group here, then you're probably gonna have to factor out a negative to get that sign to flip. And so now that I have a common factor here, I'm going to factor out that factor. Okay, so I took my 2x minus 1, which is a common factor between this product and this product, and I pulled it out front. And then we just have the 3x minus 7 left over. All right, with that said, guys, it's been demonstrated.